This production line moves at 12,000 noodle blocks per hour. When the steam injection fails, the line doesn't slow down. It doesn't stop. In 30 seconds, 600 improperly cooked blocks are already packaged. In 3 minutes, the entire batch is contaminated. 24,000 units. 40 minutes of production. Gone. This isn't about making ramen. This is about mass production at industrial scale, where one wrong decision stops everything cold. Welcome inside a factory you've never seen before. Instant ramen, the fastest produced food product in modern manufacturing. A single facility can produce 100 million servings per month. Operating nonstop, 24 hours, 7 days. The production line runs continuously at 200 blocks per minute. That's 3.3 blocks every single second. At this speed, there is no margin for error, no time to react, no second chances. The entire process, from raw flour to sealed package, takes 12 minutes. But only 3 decisions in that 12-minute window determine whether production succeeds or stops completely. And when it stops, the losses are immediate and irreversible. Let's break down where failure happens. Stage 1. Dough mixing and sheeting. Flour becomes thin sheets. Stage 2. Cutting and waving. Sheets become noodle strands. Stage 3. Steam cooking. First critical decision point. Stage 4. Frying or air drying. Second critical decision. Stage 5. Cooling and seasoning. Stage 6. Packaging and sealing. Third critical decision. Everything flows without stopping. But stages 3, 4, and 6 are where one wrong parameter creates cascading failure. Let's examine what really happens when these decisions fail. The noodle strands enter the steam chamber. Temperature, 100 degrees Celsius. Duration, 90 seconds. This is gelatinization. The starch molecules in the flour absorb water and swell. The noodles become partially cooked. But here's where most factories lose money. The steam temperature must stay between 98 and 102 degrees Celsius. The margin is 4 degrees. If temperature drops to 96 degrees, gelatinization is incomplete. The noodles remain raw inside. When the customer adds hot water later, they won't soften properly. The texture is wrong. The product fails quality control. But here's the critical part. This failure is rarely visible at first. The noodles look normal. They pass visual inspection. They get packaged and shipped. The failure only appears when the customer opens the package weeks later. By then, 20,000 units from the same batch are already distributed. Full product recall. Total loss. If temperature rises to 104 degrees, over-gelatinization occurs. The noodles become mushy. Structural integrity collapses. They break during frying. The entire batch becomes waste immediately. 4 degrees. That's the difference between production success and full line stoppage. From an engineering perspective, this is controlled starch transformation under time pressure. The line moves at 200 blocks per minute. In 90 seconds, 300 blocks pass through the steam chamber. If the steam system fails for just one cycle, 300 blocks are improperly cooked. At $2 per block wholesale, that's $600 lost every 90 seconds. But it gets worse. The steam chamber can't be stopped and restarted quickly. The temperature recovery time is 8 minutes. During those 8 minutes, the line continues running. 1,600 blocks pass through at incorrect temperature. By the time sensors detect the deviation and operators react, $3,200 worth of product is already compromised. This is why the factory uses redundant steam boilers. 3 boilers running simultaneously. If one fails, the others compensate within 5 seconds. Temperature sensors at 4 points inside the chamber. Real-time monitoring. Automated valve control. Because in mass production, there is no time to react manually. But steam cooking is only the first decision. The next one is more expensive. After steaming, the noodles enter the frying chamber. Temperature, 140 to 150 degrees Celsius. Duration, 2 minutes. Frying serves 2 functions, moisture removal and flavor development. The target moisture content after frying is 3 to 5%. This is what makes instant ramen shelf-stable for 12 months. But the oil temperature control is where production stops cold. If temperature drops to 135 degrees, moisture removal is incomplete. The noodles retain 7 to 8% moisture. Here's what happens next. High moisture creates conditions for microbial growth during storage. The product spoils within weeks. Failed safety testing. Another full batch recall. But this failure is even harder to detect than the steam issue. The noodles look identical. They pass weight inspection. They get sealed in packages with oxygen absorbers. The contamination only becomes visible after 4 weeks in storage. By then, 50,000 units from multiple production runs are in distribution. The cost isn't just the product. It's transportation, storage, shelf space, and brand damage. One temperature deviation, exponentially larger loss. If temperature rises to 160 degrees, the oil begins to break down. Free fatty acids form. The noodles develop a rancid smell. Customers complain immediately. But there's another variable that makes this decision even more critical: oil quality degradation. The frying oil is continuously recycled. Fresh oil is added to replace what the noodles absorb. But the oil degrades over time. Oxidation occurs. The oil darkens. Viscosity changes. Heat transfer efficiency drops. If the oil isn't replaced at the correct interval, even perfect temperature control won't produce correct moisture levels. In industrial practice, this is where mass production meets chemistry. The factory monitors oil quality in real time using optical sensors, color, clarity, and free fatty acid content measured continuously. Automated oil filtration removes particles every 2 hours. Complete oil replacement every 12 hours. The production line processes 14,000 blocks in 12 hours. If oil replacement is delayed by just 1 hour, approximately 1,200 blocks are fried in degraded oil. At $2 per block, that's $2,400 lost. But the real cost is quality consistency. Inconsistent frying creates inconsistent texture. Customer complaints increase. Brand reputation suffers. This is why prevention costs less than correction. Oil quality sensors cost $5,000. A single day of quality failures costs 20 times that amount. But frying isn't the final decision. The most expensive failure happens at packaging. The fried noodles exit at 70 degrees Celsius. They must cool to 40 degrees before packaging. Cooling time, 3 minutes. Forced air circulation. Then the noodles move to packaging. This is where everything can fail in seconds. The package is sealed using heat. Sealing temperature, 170 degrees Celsius. Duration, 0.6 seconds. The seal must be airtight. Any oxygen inside the package causes oxidation. The noodles become rancid within weeks. But here's where the failure cascade reaches its peak. If sealing temperature drops to 160 degrees, the seal is incomplete. Microscopic gaps remain. Air leaks in slowly. This failure is invisible during quality inspection. The package looks sealed. It passes the squeeze test. It gets shipped. The oxygen leak is so slow that degradation takes 4 to 6 weeks. By then, 80,000 units are already in retail stores worldwide. Full product recall across multiple countries. Transportation costs. Import fees paid twice. Disposal fees. Regulatory fines. One sealing failure. $1.6 million in total loss. If temperature rises to 180 degrees, the plastic melts excessively. The seal is too strong, but the package is damaged. Visual defect. Immediate rejection. At 200 blocks per minute, a 10-second temperature spike affects 33 blocks. But the real problem is detection time. The sealing machine has temperature sensors, but they measure the heating element, not the actual seal point. There's a 5-second delay between element temperature and seal temperature. In those 5 seconds, 16 blocks are already sealed incorrectly. This is why modern lines use infrared cameras. They measure the actual seal temperature in real time. Non-contact measurement. Instant detection. If temperature deviates by 3 degrees, the system alerts operators within 1 second. Defective packages are automatically rejected before leaving the line. This level of automation exists because once this fails, there is no time to react. The production line continues moving. Every second of delay compounds the loss. But there's one more factor that makes packaging the most critical decision: cumulative failure. If steam cooking was incorrect, the noodles are already compromised. If frying was wrong, moisture content is off. If packaging fails, oxidation finishes the damage. Each upstream error multiplies the downstream cost. What starts as a 4-degree steam deviation becomes a $1 million packaging failure 3 stages later. After packaging, every production batch undergoes testing, visual inspection, weight verification, seal integrity testing using vacuum chambers, moisture content analysis, random sampling, 1 block per 1,000. If it fails, the entire 1,000-block batch is quarantined and retested. Industry standard rejection rate, 2%. This facility, 0.8%. That's the result of real-time control at 3 critical decision points. But here's the economic reality. At 100 million blocks per month, 0.8% rejection equals 800,000 blocks. At $2 per block, that's $1.6 million in monthly loss. At industry standard 2%, the loss would be $4 million per month. The difference, $2.4 million, saved every single month through precision control. That's $28 million per year. And that's why automation, sensors, and redundancy aren't optional in modern manufacturing. They're the difference between profit and catastrophic loss. 3 decisions, 3 failure points, 3 escalating losses. Steam cooking, 4-degree margin, 90-second window. 1 failure affects 300 blocks. $600 lost in seconds. Frying temperature and oil quality, 15-degree range, continuous monitoring. 1 deviation affects 1,200 blocks. $2,400 gone. Packaging seal, 10-degree window, 0.6-second seal time. 1 failure triggers recalls. $1.6 million total loss. This is modern food manufacturing at industrial scale, where 12,000 blocks per hour means 0 room for error, where 1 wrong decision doesn't just stop the line. It stops distribution. It stops sales. It damages reputation. And where small decisions made too late cost exponentially more than prevention. That's the reality inside a factory you've never seen before, where ramen becomes mass production, where seconds determine millions, and where 1 wrong decision stops everything cold.